Continue. Okay. All right. So first slide, right? Just in general, right? A couple ideas. Hopefully we have some basic uh, understanding this anyway, right? What a battery is. A battery has a positive and a negative terminal on them, right? One is called the, um, right? Our terminals, excuse me. So there's a potential difference between them, right? Positive, by definition, we're going to still use um, we're going to still use the same stuff we did from the last unit. So the positive has the high potential, negative has the low potential, right? Um, but they happen because there's a chemical reaction going on, an oxidation reduction reaction, uh, which sounds like I know what the hell I'm talking about, but honestly, my chemistry knowledge is limited. So, but it's an oxidation reduction, which one of them has, we're adding hydrogen atoms to one of the terminals and taking hydrogen atoms off of the one of the terminals in the chemical reaction. Is that correct? Does anyone have AP Chem or just remember from honors chem?
Yep.
What? Yeah, am I kind of at least saying the right words, even if I'm not really sure what they mean?
Yeah, stripping electrons from
Okay,
something.
yeah.
Yeah.
So that's what's happening in the battery, right? With the two different terminals, and we end up with a positively charged terminal and a negatively charged terminal, and that gives us a potential difference between them. All right. So the voltage, the battery is the voltage, the potential difference. Okay. Next thing in a circuit. Why is it not changing? There you go. All right. So what is a circuit? Right. A circuit is a closed. This is important. A closed continuous path connecting the two terminals, and the current. Right. So in this picture of our circuit here, I'm kind of skipping this picture of our circuit because the switch is open. There is no. The light is not on. Right. There's no way for the charges and the current to flow um, through the circuit because the circuit is broken. It needs to be a closed continuous path for the circuit to go, and that's all switch is. It's something that opens and closes the path in the circuit. So electric current is the flow of charges through the conductor, and the value of the current is the charge per time, coulombs per second. We're not going to do the conceptual example, but the key out here is it's the rate the charges are moving, right? It's not the speed the charges are moving. A greater current does not mean the charges are moving faster than a lower current. All current goes effectively at essentially the speed of light through the wires. Not quite, a little bit slower than that, but really fast, and they all go the same speed, no matter how much current there is. Current has to do with how much charge is going. All right, and I emphasize that because it's a common misconception, right? That a higher current in your means that the electricity is moving faster. That is not the case. Higher current just means more charge is moving. Okay. Any questions? Beautiful. We're moving on to the third and final slide before we get to the lab. Okay. So the other thing that we're going to do here, talk about in our lab, is the resistance. Right. Resistance is as it says, right. I don't have to um, read the sentence to you, the definition of resistance to you. But the important thing for us to understand is the resistance is generally, it's the thing that's using the electricity. It's the device that's using the energy. All right. Wires do have some resistance, but it's minimal, especially in your everyday setting. Like power lines have a higher resistance, but like the wires in your home, or the wires in your computer, or the wires in your cell phone where the electricity is flowing, have relatively effectively zero resistance. It's the devices that are using the energy that offer the resistance. Okay. And the other thing important it is resistance, right? It says it impedes the, all right, impedes the current. So resistance kind of is the thing that reduces the amount of current. It does not slow it down. It just reduces the amount of current that the battery is able to produce and the amount of charges that are able to go through a given circuit. Okay. So voltage, current, and resistance. Those are the three key words for us for today and for the lab. We good? Any questions?
Can you real quick go to the second slide?
I can go back to the second slide. There you go.
All right, thank you.
You're welcome. All right. If there are no other questions, I'm going to end the share and we're going to start to do the lab. Okay. All right. I'm going to take silence as you are good to go. So stop sharing this. I'm going to move my camera so you can see all of the stuff on the table here. All right. So I got all this stuff on the table. Let me move some of the stuff out of the way. All right. This is effectively, this is going to be our battery. All right. This is a power supply that can vary the voltage, right? The dial here on top. As I change the dial, I can vary the voltage. I have 3 light bulbs. Whoops, 1, 2, 3 light bulbs. I have a bunch of wires to set up our circuit. And then I have 2 multimeters. These are meters to make measurements. We're going to measure the voltage and the current in this lab. All right. So the data you're going to collect, if you have the lab in front of you, you've read it. The data we're going to do is we're going to compare voltage to current. Okay, actually current to voltage. Current is going to be our independent variable. So when we make the graph, the current's going to go on the x-axis and the voltage is going to be the dependent variable that's going to go on the y-axis when we make our graph with our data. Okay, so we're going to repeat it 3 times. We're going to do it once with 1 light bulb in our circuit, once with 2, and then once with 3 light bulbs in our circuit. All right, we ready? Okay, so I'm going to take my wire, hook up my circuit here. Okay, there's a 1 light bulb. From the light bulb, it's got to go back to the terminal. Why won't this hook in? Stay. Come on. Come on. Nope. I was doing this on Friday. It worked. Why can't I get it to work? There we go. And then back to the terminal. But in order to do this, to measure the current, I need to run it through my meter here. So I'm going to go through the meter first and then take the meter and send the meter back to the battery here, or volts. So when I turn this on, you can see the light bulb lights. Can you see the light? Oh, you can't see the light bulb light, right? You can see the light bulb lights. Okay, so let me set up here we go. And then I'm also going to measure with the other meter. I'm going to just put them into the battery here so I can measure the voltage. Okay. Okay, here we go. Right. So first data point, 0 voltage gives you 0 current. This is our first data point. Actually, I should do it the other way, right? Zero current gives you zero voltage because current is our independent variable. Let me move this or change this. All right, so I'm going to vary the current, increase the current here. Turn the, so the light bulb starts to glow. I have a current of 0.201, 0.2 amps. Let's just go with 0.2 amps. And the voltage that is associated with that is 1.25 volts. Okay, 0.2 amps, I'm sorry, I said it wrong for the voltage. I apologize. 0.2 amps, 1.825 volts. 1.825 volts. Okay. Here we go. I'm going to change the voltage or the current again. The light bulb should start to get brighter. Let's go up to, see if I can, I'm going to try and set it at 0.3. Here we go. 0.3 amps of current, 4.0 volts. 0.3 amps, 4.0 volts. Okay. Moving on. I'm gonna have to, if I get too bright, I'm gonna burn out my light bulb, so I have to be careful here. So I might have to go in smaller intervals of current. So let me see if I can get this to, I'm gonna try and get it to 0.35. There we go. 0.35 amps of current, 5.4 volts. 0.35 amps, 5.4 volts. Okay, moving on. 0.4 amps of current, 6.9 volts. All right, 0.4 amps, 6.9 volts. Shit. Lost my battery or lost my light bulb. All right, so we'll just, if I replace the light bulb, you know, it's gonna screw up our control. So we'll leave it at that set of data. Okay, how many data points did I have there? We have like 5. Did we get 5 data points at least?
Yeah, 5, including 0.
Including 0, that's not ideal, but it's okay. We'll just deal with it. Let me go get another light bulb out of my box here. Okay, here we go. We're gonna go on to reset it. I'm gonna add a second light bulb into the circuit. Okay. So, right, and new, hopefully, obviously, when you do go to graph this, you're going to do 3 different graphs. One for, you know, 1 light bulb, one for 2 light bulbs, one for 3 light bulbs. Okay, so let me reset. Here we go. Again, start at 0, 0. Okay. Can you start to see the light bulbs glowing just a little bit? Right, they're just glowing just a little bit. Here we go. Let's start with a current of 0.15 amps. All right, current is 0.15 amps. And the voltage is 1.9 volts with 2 light bulbs. 0.15 and 1.9 volts for our 2 light bulbs. So hopefully we're going to see, in addition to getting numbers, you're going to make some observations, just general observations about what happens to the brightness of the bulb. So this time we're at 0.2 amps of current. 0.2 amps gives us, hold on, 3.54 volts. Okay. Moving on. 0.25 amps of current. 0.25 amps of current. 5.4 volts. Okay. Continuing. Trying to get to 0.3 here. There we go. 0.3 amps of current, 7.7 volts. Okay. Starting to get a little bit brighter. I don't want to burn them out again. So let's do a little concerned here. I'm going to go a little more conservative. 3.3 amps of current, 3.3 amps of current, 9.35 volts. How many data points do we do there for the two bulbs?
Wait, how much current was the most recent one?
The current is 0.33. And the voltage is, what did I say? 9.2, right, is the voltage. It's jumping around here, hold on. 9.3 is the voltage, I apologize. Okay, do we have, how many data points? Do we have like 6 or 7 data points?
6 including 0.
Good enough. All right, I'm gonna go back to here. I'm gonna add a third light bulb and then we'll do it one last time, all right? And another wire. I didn't bring enough wires here. Come on. Okay, here we, nope, there it is. Nope. Keeps, come on, stick in there. There we go. Okay, so again, now we have 3 light bulbs, right? Can we see all 3 light bulbs light? Yes. All right, here we go. Ready? Again, we're starting at 0, 0. Okay. Let's start with, I'm concerned again that I'm going to burn out the light bulbs. So we're going to go a little bit smaller intervals for this one. All right. Come on. Come on. Might need to go even smaller than that. All right, here we go. 1.5 amps, or excuse me, 0.15 amps, 0.15 amps. The voltage is 2. Why is it jumping around on me? Let me see if if this works better, if I can do this. All right, 0.15 amps of current, 2. 0.85 volts. Okay. Here we go. Moving up. To 2.0 amps of current. 2.0 amps of current, 5.3 volts.
Mr. Shukit, is it 0.2 or 2.0 amps?
0.2.
Okay.
Okay. And 0.25 amps next is 8.0 volts. All right, 0.25 amps, 8.0 volts. I might even have to go in smaller intervals. All right, I think I'm gonna go even smaller intervals here. All right, 0.27 amps, 9.5 volts. Zero point 0.3 amps, 11.6 volts. Getting fairly broad. I think I can get a couple more in. How many? Oh, we have like 5 or 6 data points.
6th including 0.
All right, we'll do one more here. All right. .32 amps, 13.2 volts. Okay, so, right, couple of just observation things. Hopefully we're seeing that the light bulbs are, you know, obviously get brighter as you increase the voltage, right? And I also wanted you to kind of compare what happened here with 3 volt. That was me. I did not burn out. I just, the wire came disconnected. Right, we're up to, with 3 light bulbs, we're up to 13 volts, 13 plus volts, right? With the single light bulb, it burned out at what, somewhere around 8 volts, right? The amount of current with a single light bulb was a lot greater than the 3 light bulbs. All those types of things, observations, right? Again, that was not burning out. That was the wire coming disconnected. The brightness of the light bulbs, I'm going to set it at, right? Let's compare 3 light bulbs. I'm going to go back on my voltage. If I do, let's say here, right? You can see how dim, you can almost not even see the light, right? They are lit just slightly. I don't know if you can even see it. There's just the slightest dim lit. At this voltage, if I just take a light bulb out of the, and we go the same voltage. Uh-oh, ruh-roh, what did I do? What did I do? Oh, I put it in the wrong, connected it to the wrong thing. When we go to 2 light bulbs, the same voltage for 2 light bulbs. Is a little bit brighter than it before, right? You could almost not see it at all. And then the same light bulb for a single light bulb gets a little bit brighter even there, from there, right? So just some little observations, not, you know, other than the numeric qualitative observations rather than quantitative observations, right? The same voltage produces, with the fewer light bulbs, produces a higher amount of light, a brighter light, I should say. Okay. All right, guys. So it is 10:54. We are together here for another 15 minutes. So what I'm thinking is, I want you, if you can graph your data and stuff tomorrow, what we can do is we'll take a little bit of time to go over the FRQ, and then you can use the rest of the time to just finish the lab, right? You need to get, so your judgment on what you're going to need to do. You're going to need to graph all three, come up with a best fit curve in there, an equation, and then a brief little summary. So that'll be due at the end of the period tomorrow. So your judgment as to whether you need to work on it tonight. Okay? Any questions? I'm going to stop recording because there's nothing new.